Hello everyone. My name is Ritesh, and our today's topic is play ball for grade 6. Now, by play ball, you may have assumed a cricket ball or tennis ball, which we usually play. Exactly. And what it depends on, it is motion. So, today we are going to study about motion. Now, motion you might have in your syllabus. So, motion in physics is a change with time of position or orientation of a body. Like maybe a position or object have just slided some distance forward or backward, or orientation of the body you just have rotated. Let's say you have rotated a chalk, so it changes its orientation of. So, motion along a line or a curvature is called translation. So, if motion is like straight or on a line or a curve, we call it as a translation motion. And motion that changes the orientation of body is called as rotational motion. So, for rotational motion, you can just think of example of a fan, and in linear motion, you can just imagine a person sliding a box in somewhere. So these two are some basic examples of what rotational motion and translation motion. So, but in both the cases, all the points in the body have the same velocity and the same acceleration. So, like velocity is the directed speed at which each and every atom is moving um, with, and then acceleration is the time rate change of velocity. That's right. And then the most general kind of motion combines both translation and rotational motion, which you may observe at your surroundings. Most of the motions usually they consider both of both kind of motion, rotational and translation. Then all motions are relative to some frame of reference, like uh, we may observe something from a distance, we can say. So we'll be seeing that. So saying that a body is at rest, which means that it is not in motion, and merely means that it is being described with respect to a frame of reference that is moving together with the body. For example, a body on the surface of Earth may appear to be at rest, but that is only because the observer is also on the surface of Earth. The Earth itself, together with both the body and the observer, is moving in its orbit around the Sun and rotating around its own axis. So that's why for the person who, for the observer and um, the person who may, so observer will see that the person is at rest, but for example, an astronaut, so he might not see the both of them at rest because Earth is moving along its axis and also covering a distance around the sun. So for an astronaut, those both of the persons are in moving, but for this observer, the person is at steady state because they both are on the same surface, or we can say at same frame of reference. Now, for considering another example, you might observe when you will be traveling in a train. So you might see that person in front of you or besides you. You may seem it may seem that it is at rest because you are in a same uh, frame of reference. But when you observe someone outside, you may see that it is moving backwards because uh, you and that person outside the train, you both are at different frame of references. That's why you observe the person beside you at rest while the some other person outside the train in the motion. That's some other common example. As a rule, the motion of bodies obey Newton's law of motion, and however, motion at speed close to the speed of light must be treated by using the theory of relativity, and the motion of very small bodies such as electrons must be treated by using quantum mechanics. This quantum mechanics is very high level, so we are going to study that far later. But if you are interested in studying what is theory of relativity, let me tell you that it consists of two theories, like named as special theory of relativity and general theory of relativity. So, what special theory of relativity tells us is like it gives us a description between, or we can say, it gives us data in reference to time and space time things. And general theory of relativity, we can say it is the simplification of special theory of relativity, and it may be stated like it usually gives us the relative things of gravity, mostly related to gravity. So, using the special theory of relativity, there are much more examples. If you go and search on just Google, you can get everything regarding that. And trust me, it is very interesting. If you are really interested, just go and study that. So, you might get some extra knowledge and valuable for you also. So, these are the things, and here we can see some types of motion with the examples. So this is vibratory motion, so we can say it is going left and right and left and right in the specific zone. So it's moving just left right, so it's like vibrating. That's why it is vibratory motion. In a linear motion, like I've given you example, a person pushing a box in a straight line, so it's a linear motion. Then here we can see a curvilinear motion. So here a boy is kicking the football, and so this is also traveling a distance forward, and it also observes a curved path in height. So it's curvy and linear. That's why its name is given like that. It's curvy and linear motion because it travels in both the direction. Then here we have oscillatory motion. You might have observed this kind of motion in, let's say, clocks majorly. So the bob of the clock is usually moving left, right. So that is nothing but an oscillatory motion. Then, for example, of a circulatory motion, you may see here is Earth and here is a satellite. So satellite is moving in a circular motion around the Earth by using, of course, gravity and forward velocity, which scientists have, or we can say it's given to it. So it basically uses centrifugal force to rotate around the Earth in a circular manner. And then at last we see here is a rotary motion. So it a fan, and its linear motion is stable, but it's just moving in a round or circle. So it's a given as a rotary motion. Now, oscillatory motion. What is the example of oscillatory motion around you? So this is one, a pendulum clock. Then what is this? This is a swing. So when you go to a park, you have a swing over there, and this is also a great example and the most common example of oscillatory motion. Now, here we have an experiment which is very nice, and it's good. It will give you some practical experiences regarding oscillatory motion. So here we have material required as a sock, um, a pair of socks and a sock single, then a soft ball, then strong long rope. It must be strong enough. Then here's the procedure. So put the soft ball in the sock, tie the end of the sock with a rope, and tie the other end of rope with an elevated and strong place. Let us consider you have hang it over a wall, sorry, above wall. Then the ball should hang at your chest height. uh, Make a note of that. Then gently drag the ball in one direction and release it. So you just have to imagine this, there is a ball like this, and then you have to just pull it in direction and then release it. So now observe closely what it happens. So if you imagine, and if you are trying right now, if so, just do that, and you will observe that ball is moving like this. So what is it? It is an oscillatory motion, like that. So it's a great example of oscillatory motion. And now, when it eventually comes to halt, don't stop it. When it eventually comes to halt, and now push the ball in a manner that it trans what traverses a circular path, and let it move till it come back to the center. Okay, now imagine here is the ball, and right now we just pulled it like this in a single direction, but now we have to just push it in a crossway direction, so that it can make a conical, uh, it may trace a conical path. So you just have to like uh, over this, and then you have to push it in a xy middle of the xy plane, like that. So uh, and then let it move to its center eventually. Now, randomly try to push the ball in any direction with mild force. Like randomly, you just tap it or just slap it or whatever. So you just have to do it randomly, and then just make the note of your observation, that what you observed, that which direction it was moving, and all kind of that observations. So now here observation. So by observing the experiment, we can say that the first instance of to and fro motion is an example of oscillatory motion, which I just told you. And then while the second instance is an example of circular motion, like I just told you that it will be moving in a conical manner. So these both are the observation. And now here's a question: what happens when oscillatory motions occur at an extremely random place? Will your eyes be still able to keep a track of actual movement? Now, see, it depends on person to person how the person reacts to a motion, and then your eyes will still be able to keep a track of the actual moment. See, if our mind recognizes that moment, then it may also track the actual moment, but it's not necessary that everybody should catch that, or at every instance our eyes would be catching that. It's completely relative, and at extremely random place keep actual moment. Yeah, so that's it, it's random. So if our eyes fall on that motion, for example, but your brain just ignores it, so that it will not keep the track of that actual moment. But if your eyes and notice it, and if you noticed it after after watching that, if you notice it with a full focus, then you may track the actual moment. Now let us see what we have learned today. So we learned about motion, and in physics, the change in time and position or the orientation of body is known as motion usually. Then there are two types of motion, like translation motion and rotational motion. Translation is nothing but in a single line, and rotational is nothing but uh, orientation, change of the orientation of that body. Then we saw about a frame of reference. Motion is relative to the frame of reference. And we have seen here an example of Earth and an astronaut observing a person on Earth, and a person on Earth observing a person on Earth. So the astronaut and the observer, they both are different are present at different frame of reference. That's why they both will observe different things. Like observer will observe the other person to be at rest, while the astronaut will observe both of the person in rotatory motion. Now we can say that in motion in general. Now again we know about theory of relativity. There are two theories inside that. So special theory of relativity and general theory of relativity. So if you are curious to know what are those, you just can Google it on Wikipedia. You can get all the information. Then the motion of very small bodies such as electron must be treated by using quantum mechanics. That is too high level for us right now, so we are not going to study regarding that. Next, we have seen some types of motion like vibratory linear motion, curvilinear motion, and we have learned why it is called as curvilinear motion. Then oscillatory motion, circular motion, rotatory motion. And here are some examples, common example which you see of oscillatory motion. Then we had an experiment where we observe three kind of motions of a ball which is hanging from a wall, we can say solid thing. Then three types of motion were, first was the rotary motion, oscillatory motion, and then the circulatory motion, oscillatory motion and circular motion. I'm extremely sorry for that. Um, and the random motion, we cannot consider it as an motion because it was extremely random. Then what happens if oscillatory motion occur at an extremely random place? Will your eyes be still able to keep the track of actual movement? Well, it completely depends on how a person is, or how much focus the person is paying, or how much attention that person is paying to that motion. Or at extremely random place, it is very difficult for our mind and eyes to see that and recognize that and remember that at the same time. So that's all for today. If you have any questions, you can just put down in the comments. I'll try to answer those. Thank you.